Let's go through LeetCode 2092, find all people with secret. So it will give us there are n people in a two-dimensional array meetings and also a first person. Um, so it says that for the meeting, uh, which it has xi, yi in the time, which means if x or y has secret, and it will pass the secret to another people at the time I. Um, Initially, it say that zero, person zero has secret, and also um, he shares a secret with the person with the first person at time zero. The secret is shared every time, so shared on the following meetings. I see that the secret are shared instinctually. That is, if there are people entering at the same time, right? So that means if at the same time there is meeting one, and there is A knows the secret, B doesn't know, right? And then A will give the pass the secret to B, and also at the same time this time if there is a B and C, right? So the secret will always also be shared with C. Um, so return a list of all people that has secret after all the meeting have been taken. You return the answer in any order. So so let's say initially there is zero in the first person. They have a secret, right? So in other time slot, there is meetings, different meetings. So if there is zero or the first person of that, right, they are going to pass the secret to the people who is have a meeting with them, right? So the thing is that if, for example, if the first person, if there are several meetings, for example, A1, right? And this A1 with A2, and this A2 and with A3, right? So we'll see this secret will be passed to all of A1, A2, and A3, right? Even there are three meetings, we can consider that at this time spot, they are joining one meeting, right? So this is some kind of, let's say, thinking about we are trying to connect some of the nodes. So we can thinking intuitively using, for example, BFS or DFS or union find, right? So at this point. So if we do BFS or DFS, right? Of course, we group the meetings by the time, right? That is group iterations. And in each time, we do BFS from the person who knows the secret to with the other meetings in this time slot, right? So in the end, we just trying to see find all of the people who has a secret. We can use a set or Boolean, whatever, to check. But use a BFS or DFS, this part, apparently, we need to traversal all of the people, right? So the worst case is that will be n people at this time slot. And the time, worst case will be OM multiplied by M meetings, right? So can we do better? Actually, if we do union find, right? We do union find, we know the union operation of union find, that is O log alpha, right? So that is like a constant. So we have the meetings to, to union those people in the meeting, right? So in this case, what we can do is that for all of the people who has secret, they are going to be union with there is a union set, right? And for all of the people at this time slot, all of the people, if they are not they are not have secret, they are also in another union set, right? So if they are not not have the for another set, they don't have secret. How can we do for these people? Should we keep their union or not? Actually, we cannot. For example, if there is an X person here, right? And X join another meeting in the later part, which with the people who have secret. If we still union these sets, then we union X and 0, right? For example, the secret person. Then it will give some problem that union all of the people in a part which don't have secret with the meeting we have secret, right? So this will get things wrong, right? So what we do is that for the set of people we do not have secret at this time, we should reunion or disconnect their connections, right? Set their parents to be itself. Set so that this will not be affected by the further unions, right? So this one, the hard part for this question is that we should also ununion, write our ununion person for all of the people in a set which doesn't have secrets. So let's write code for this. So as we talk about, we need a class union find. So there are n people. We are going to have father array in the public union find. Let's have a constructor int n, right? So we're going to father equals new int n, and then for int I equals 0, I smaller than n, I plus plus. So we're going to have father I equals I, right? And also we need a public void union int A, int B, right? So what we do is set int fa equals find A, right? Int fa underscore B equals find B. So if fa underscore A not equal to fa underscore B, then set the father fa underscore A equals fa underscore B, right? And also find public int find, for example, int x, right? So if x equals father x, just return x, right? Then we'll set father x equals find father x. This is a recursive call. And in the end, just return father x, right? So for this question, actually, instead of the basic union and find, right, we need another function called ununion or reset. So let's say we have another function called reset for a person, right? Into x. So just set father x equals x. So that's because the reason we want to reset this person is that at this time t, right? For the secret, the people who have secret, the union is meaningless. For those people which don't have secret in set, the union, we should disconnect the union, right? It's meaningless. And also, if there is a further connection unions in a later time, right? This will affect the correctness of the results. So we should reset the father as itself. So we need a reset function. Then let's write code. So we know we need sort the meetings. Sort the meetings by the time, right? A, B goes to integer, compare A2 and B2. So let's add our result to a set because it's possible there is duplicates, and then we convert this set to list. Okay, so we're going to have set integer result equals new hash set. So at a time 0, people 0 give a secret to the first person. So the person 0 and the first person, they know the secret, right? So they are going to add it to a set. Actually, for this question, the first person, this parameter is actually don't, if we give question, right, this is just confusing us. If we don't have this sentence or this parameter, it is fine as well if you give us only the person 0 has secret, right? So result add 0 and result should add first person. Then let's have int L equals meetings dot length. And we are going to up parameter called last. That means at this time, right, we have index from the last to I will have the same time for these meetings, right? Meetings. So the last is the first meeting index in this bunch of set at this time, right? So we are going to have a last equals, so initial set as 0, right? So time 0. And we need a union find UF equals new union find and at time 0 we should union first person 0 and first person, right? So let's write group iterations for int I equals 0, I smaller than L, I plus plus. So if I equals L minus 1, or meetings I 2 done equal to meetings I plus 1, 2, right? So that means we are end of the group. And we are going to set last equals I plus 1, right? So for this group of people, these meetings, right, from the last to I, they are at the same time. So what we can do is that we can do the union, right? For int j equals last, j smaller equal to I, j plus plus. So we're going to have UF union meetings j 0 and meetings j 1, right? Union these two. And as we talk about, for at this time, right? At this time, that is from the last to I, we need to check all of the members with which is affected. So the meetings 0 and 1 are all of the members who are affected, right? We check if they are connected with person 0 or not, or first person, which both will work. If they equals the first person or equals to 0, then add to our result. If doesn't equal, then we reset. So what we do is that we check again, right? Int j equals last j small. We don't need to check everyone. We just need to check the affected person. That is, the meeting has two person, right? Affected person at this time slot. G plus plus. So if there's no secret, right? So we're going to have int meeting equals meetings J, right? So if no secret, that is it is connect with person zero, find meeting zero, right? Equals UF of find zero, right? And we don't need to check meeting one again because meeting one and zero, they are connected already, right? So in this case, we just have set add meeting zero and set add meeting one, right? And if they are not connected with person zero, right? Then we should reset uf.reset meeting zero and uf reset meeting one, right? So this will be for each time slot we do the union and also add the person who has secret to our set, and also the person who don't have secret, we reset their union find, right? So that will not be affected by later time. Um, Return new array list set. Result. Okay, so we know there is a sort, right? So this sort is an OM log M, right? If there are M meetings, M log M operations. And we'll say this operation actually doesn't related to the people, right? So just relate to the meeting. So and then for meeting, the union is we can consider that is constant operation, right? So the time complexity here we'll see that is OM, right? Or OM, or say log something that is a constant. And then there is also a sort. So the total time complexity is M log M. In the space, right, there are n people, right? So it is O n. We are need a place. Worst case is n people put all to our result. Also, let's write a Python code for this. Mm, let's define a class union find and def self and int. We'll have self. We need a father, right? Equals list range and let's define find a extra int, which is return int if x doesn't equal to self dot find self dot father x, then self dot father x equals self dot find father x, right? And we just return self dot father x. So there is a recursive call and def um, union. In the union self. In the union A, which is the int, B is the int, right? So FA underscore A equals self dot find A, and FA underscore B equals self dot find B. So if FA underscore A doesn't equal to FA underscore B, so I set self dot father FA underscore A equals FA underscore B, right? And also we define, we need a reset this one, right? So for those kind of useless union, we should reset um x int. So we have self dot father x equals x, right? So this will be our union find function. And for our main function, what we need is, first we need the meetings sort by the time, right? K equals lambda x x2, right? And let's have result equals set. So initially for this set, we have 0 and the first person, right? Then let's define UF equals union find n, and UF dot union 0 and the first person. And for group iteration, for the same time, right? We need an last index. And let's also set M will be the length of meetings, right? Last index is set this one's 0, and this is length of meetings. So what we do is for I in range M. So we'll have if I equals M minus 1, or meetings I 2 doesn't equal to meetings I plus 1 2, right? So that is end of the group. So we for J in range from last to this I plus 1. We're going to union then. So we're going to have x y equals meetings j, right? So we have UF union x y. Then we check whether they are union with 0, that is, they have sequence or not. For j in range from last I plus 1, right? Then we're going to have, so we also have xy underscore equals meetings j. So if uf dot find x equals uf dot find 0, then we're going to have a result up add add x and the result add y. Else we need to reset. Else uf reset x, uf reset y. And for this we need to have set this last to be I plus 1, right? Then in the end, we just return list result. Father is not defined. Self dot father equals list range n. Self dot father equals list range n. Then find other x. There is a self here. Okay, so this is a code.